Okay, let's do another one. This segment is just about creating the t probability distribution drawing, putting the appropriate information on the drawing, and we're building on what we did a couple segments ago in terms of how to choose the correct t value. So let's do another one. N equals 25, 98% confidence intervals. N equals 25, 98% confidence intervals. First, the drawing. I'm going to first draw another facsimile of the normal probability distribution. Bell-shaped, symmetrical, perfect. Not really perfect, but we'll pretend it's perfect, okay? How much area is underneath the whole thing? The whole thing? 100% or 1. Okay? What's our task at hand? What have we been asked to do? We've been asked to create or account for how much of the distribution in the middle? 98%. So that's what that would look like. In other words, this piece right here accounts for 98%. So almost the whole thing, 98%, which means how big does each of these smaller pieces on the edge? The tails are what those are referred to as. How big do each of those tails need to be, or how much are they? Not need to be, how much are they? If you said 2% total or 1% each, you are correct. 1%, that's how big. We're talking about area again. 1% and 1%. Right, quick. What's 1% plus 98% plus 1%? Right, 100%. Now let's add our legend. Let's add our legend. N equals 25, which means degrees of freedom equals 24. And our task at hand is 98% confidence intervals, which means our t value is, let me show you, that's just a legend. N equals 25, degrees of freedom equals 24, n minus 1, 98% confidence intervals, which means our t value is 24, what the heck? Sorry, n equals 24, 98% confidence intervals would be 2.492. T equals 2.492. So I just added that right there. But wait, let's also make sure we put the t values where they belong on the drawing as well, under the abscissa. So t equals 2.492 on the right. T equals negative 2.492 on the left. And that's what that would look like. What does 2.492 mean? Well, that's a t-value, which means it's standard error, units of standard error. But in this context, it's how much standard error we could expect to occur by chance alone under certain conditions. What conditions? A sample size of 25 or degrees of freedom of 24 and 98, accounting for 98% of the probability distribution. Let's do another one. Number 3. N equals 10, 80% confidence intervals. N equals 10, 80% confidence intervals. All right, same drawing as before. I think I might have mentioned in a previous YouTube clip, like if you're tired of me drawing the bell curve, don't be, because it's going to happen a lot. Again, same shape roughly, symmetrical, bell shape, perfect, sort of. Except this time, what's our task at hand? 80% confidence intervals, which means we need to account for 80% of the distribution in the middle. That means that middle portion is 80%. Well, if that middle portion is 80%, how much do these tails need to be total? If you said 20%, you are correct, except because of the property of symmetry, that means that each tail size is 10%. 10%. Quick, what's 10 plus 80 plus 10? That's right, 100%. So let's put the information that we know. Let's see, N equals 10, degrees of freedom equals 9, 80% confidence intervals, which means our t value is degrees of freedom 9, 80% confidence intervals, degrees of freedom 9, 80% confidence intervals, 1.383. 1.383. That's the legend. N equals 10, degrees of freedom equals 9. Our task at hand is 80% confidence intervals. Our t-value from the table, from the t-table, that's how much standard error we could expect to occur by chance alone, given certain conditions, a sample size of 10 or 80% confidence intervals. And so now we know our t-value, so we can put a t of 1.383 on the right and a t of negative 1.383 on the left. Let's do the fourth one. N equals 30, 99% confidence intervals. N equals 30, 99% confidence intervals. We start with the same, the bell-shaped curve. We need to draw 95% confidence intervals, 99% confidence intervals, which means that middle portion is going to be 99, or account for 99%, almost the whole thing, 99%. Well, if that middle is 99%, how big does do the tails together have to be? Now think about that carefully. How big do the tails together have to be? 1%, which means each one of them individually is 0.5 or half percent, 0.5%. So let's add that. 0.5%, 0.5%, 0.5%. Quick. What's 0.5 plus 99 plus 0.5? That's right, 100%. Let's add our legend. N equals 30, which means degrees of freedom equals 29. Our task at hand is 99% confidence intervals, which means our t-value is degrees of freedom 29, 99% confidence intervals, 2.756, 2.756. T equals 2.756 on the right. T equals negative 2.756 on the left. That's what that looks like. The bell-shaped curve, that is the T probability distribution. We have created a drawing, which means we're trying to account for 99% of the distribution in the middle, which means each tail, the size of each tail is 0.5%, and then we have the legend right here. N equals 30, DF equals 29, 99% confidence intervals, t-value of 2.756, t of negative 2.756 on the left, t of positive 2.756 on the right. Just for good measure, let's do the last one. Last one. N equals 21, 95% confidence intervals. N equals 21, 95% confidence intervals. Okay, first things first. And my drawing is really bad on this one. 95% is the chunk in the middle, which means each tail needs to be 2.5% on its own. 2.5%, 2.5%, which means the tails together are, what's 2.5 plus 2.5? That's 5. The tails together are 5%. 2.5 plus 95 plus 2.5 is 100%. And let's put the legend. N equals 21. Degrees of freedom equals 20. 95% CI, which means our t-value is 2.086, which means a t of negative 2.086 on the left and a t of positive 2.086 on the right. Let me box up my legend there. There you go. So N equals 21, 95% confidence intervals. N equals 21, degrees of freedom of 20, 95% confidence intervals. The t-table tells us that given a sample size of 21 and 95% confidence intervals, we would expect or anticipate 2.086 units of standard units of standard error to surround that mean. So we'd made the drawing, 95%, 2.5%, 2.5%, t of negative 2.086 over here, t of positive 2.086 over there.